Hello there, Vince here from my mate Vince, and in this episode today we're going to be looking at this Ring 4 amp battery charger and maintainer. So it will charge up your car and motorbike batteries and also maintain them as well. The idea being is if you've got maybe a classic car that you don't use very often, you might just want to plug it in all the time to maintain that battery so that when you do take it out once a month, you know the battery is working fine. So you have different options here. You've got 12 volt car, 12 volt car winter, which puts a little bit more voltage in, and then you've got 6 volts for the motorbike and also 12 volt for the motorbike as well. To me, this thing looks absolutely brand new. Looks like it's never been used at all. So why has it failed? It's down as no power, and that's exactly what it is. You can see we're turned on here, we've got it onto a battery here on the correct way round, and there's no life from this whatsoever. Let's bring it over to the map and let's see if it is working. Of course, you can use it as a charger as well. If you've run down your battery, then you can plug this in and it will work as a normal charger as well, not just a maintainer. Okay, first things first, let's check the fuse. No way. Fuse is gone. A 3 amp fuse. Right, okay. Let me put a 3 amp in and see if it comes alive. Imagine that. Mind you, what caused the fuse to blow? I was thinking the fuse just looks very old. Unless, of course, you don't know with an Amazon return like this. It could be that maybe, you know, like Amazon don't care, do they? If you're unhappy, you can take something back. But maybe if you were not quite so sure, you might think, oh, I don't like it. I only bought a 4 amp one. I wanted an 8 amp one for my van. And then you might think, put a fuse in it, that's faulty. And then we can pretend it's faulty. Possible, isn't it? Right, let's see. There might not be anything wrong with this. Or the fuse might blow again straight away. Tell you what we'll do, should we see if there's a short? No. Well, that's plastic anyway, yeah, so there's no short there. It should be okay to plug in, but maybe when it's energized, the short will come. Right, here we go, I'm going to plug it in now. See what's going to happen. Nothing, but I'm not plugged into a battery. Should we see if the fuse has blown again? No, it hasn't. Right, let's plug it into the battery and bring it into the other room. Let's see if it's now working. Right, we're plugged in, turned on here, and still no power whatsoever. So I'm going to say now that because its main's going into here, because the fuse was blown, that the damage inside will be catastrophic, and this will not be fixable, because often on mains things, when something goes, often it takes out numerous components, but let's see. Right, various screws around the back here. Now, although I'm unplugged, I still have to be careful because there will be a big capacitor in here and it would have enough voltage in possibly to shock me. Okay. Again, it just looks new. Everything looks brand new. Little fuse here. I suppose we could start at the fuse. Initially, I can't see any like burnt anything or any you know, blown up components, which is good. In fact, where's the massive capacitor? Oh, here's the capacitor just here. Right, so I need to take this board out. 1, 2, 3, 4 screws holding this one in, and let's check out this capacitor. So this is the main voltage coming in, and this is the low voltage coming out. Got massive heat sinks here to get rid of the heat from these, whatever they are, switching transistors. Right, let's see what's happening on this capacitor just here. So we've got the bridge rectifier there. Again, I can't see anything burnt on this side. I'm wondering if the fuse has just blown. Right, volts DC. No. So possibly the voltage hasn't even got here. Let's go on to continuity And let's check this fuse. So there's a fuse just here. So it's going to be jumping this little gap. I bet it's gone. Yeah, it's gone. Right, okay. So what's caused that to go? Let's go on to the bridge rectifier. No, we have a short there. We got a short between the AC and the DC. Yeah, we've got a short here. Right, okay, that's not good. Well, that explains why the fuses and stuff have gone. But now, what is it? Just a bridge rectifier, or did something take out the bridge rectifier? And has the bridge rectifier taken out anything else? In fact, where is like the chip that controls everything? Let me check this thing here. This like switching transistor type thing. I don't know, maybe. I'm not sure. Not sure. I don't think there's any shorts there. Right, I'm going to look up these ones here. So the bridge rectifier is an ABS10, but it also says GKA49. And then the fuse is a 2 amp fuse, basically. So I might have them. Do you know what? I mean, great if it is the bridge rectifier that's failed, but I'm not sure whether, have I ever come across a bridge rectifier? Yeah, I have actually, on a power line adapter. I have, yeah. So I suppose it is possible, because often other things go that take out the bridge rectifier, but like a chip. But in this one, maybe the bridge rectifier has just gone, but I don't think it's overly common, but I have seen it once before. Well, I haven't got the same bridge rectifier, but I've got something similar. So the one that's in there now is a 1 amp, 1000 volts. But remember, in the UK, we've got 240 volts going into it. I've got these ones here, CPC, and they are this one here. It's a 2 amp, 600 volts standard bridge rectifier. It's slightly bigger because it's more beefier because it's 2 amp, but I think I will be able to make it fit. You can actually buy these ones on eBay relatively cheaply. I think I can get 10 of them for £5, that sort of price. So it's not, that's a UK seller as well. So I probably will do that, and then I know it's as it was manufactured, as it was designed. I now need to see if I've got a 2 amp fuse. But for today, I'm going to be putting one of these in to see if it starts working. See, I'm not convinced the bridge rectifier is the only problem. Well, I found myself a 2 amp fuse, which seems to be the same size as the other ones. That should be a nice, easy swap over. 2 amp, 250 volts. So let's get both these in, and let's see if anything comes alive, or if they're going to blow again straight away. This is where, I still haven't made one, but if I had one of those lamps in series, you know, if you get like a 100 watt incandescent bulb in series, then if there was a short, which there was, then it's going to light up the light and it will save my components. And if it lights up the light, you quickly unplug it, and then it's saved your components. So I need to sort myself out and try to get one of them made. Now this one I've already used somewhere. I'm hoping it's still working. Oh, it's a lot bigger. But you know what? It's still going to be fine, because look, it's there's still plenty of demarcation between everything, and these are 4 separate pads. It's actually going to fit. It's actually going to fit nice, I think. It will probably, do you know what? It will look nice on there, because it looks like the original pads. Can you see? Oh, that's clever. How they've designed it. They've designed it for 2 different size bridge rectifiers. If you have a look here, can you see? Right now we're on the inside pads, but they've also made bigger pads on the outside, and those bigger pads are going to suit this one perfectly. So you can see we're going to have AC in on this side and then DC out on that side with the negative and the plus. And those 2 little wiggly lines here, they're the AC. Yeah. You see here, there's no wiggly lines, but because you have a plus and a minus here, that's better, you can see there, plus and minus. But also, look, the board's labelled up, which is nice. Minus, plus, or negative, positive, and AC. And with the fuse, it doesn't matter which way it goes in. you know, it's not polarity conscious. Right, let's get these in. So I'm not going to bother unplugging everything. I don't think I need to. First of all, let's unsolder that fuse. Just going to add some leaded solder to it to begin with. It'll make it easier to come off because it lowers the temperature down a little bit. Because leaded solder melts at a lower temperature than unleaded. So it just gives you just a little bit more working time. Right, I'm going to just try to go back and forth, back and forth, back and forth, and hopefully this will ping off. I'm putting a bit of pressure underneath it. So I'm just going to go back, forth, back, forth. And I think we're out. Are we out? Nearly. There we go. Now I'm going to clean up those holes. Lovely. I'm just going to put one into a hole, but then I'll straighten up the legs. So it's going to hold it, and I'll straighten up that leg there. By just straightening up the legs, you're making it easier for someone in the future to take it out. Not that it really matters. I think things like this, realistically, people probably won't be repairing. Right, okay, so that's nicely on there. Let's chop those legs off. And now we're going to do the bridge rectifier with hot air. You know, looking at the other components, I'm going to actually say that it was the bridge rectifier that failed, because everything else just looks nice. It might have just been a manufacturing defect, and the very first time it turned it on, it just popped. So let's add a little bit of flux here. And I've got my temperature set to 450 degrees Celsius. Airflow is 140 out of a possible 200. Let's leave it at that. Oh, first of all, let's have a little look. I want to see if these are wave soldered. No, I personally can't see any little bits of glue holding each thing in. So when the solder melts here, this should pop off nicely. Right, the solder's starting to go shiny. There we go. Now I'm going to add some leaded solder to that. On these bigger pads. And some more flux. I want to try to get this a little bit more level if I can. There we go. And now we're going to try to get this bridge rectifier on here. So let's get it the right way round so I can see the AC and the DC. So it's going to be like that. Right, let's leave it there so I can grab it easily. I'm going to heat it up to begin with. Right, they've melted because they're nice and shiny. So I'm going to put this on now. And try to get it into position. I think my legs might be a bit bent up. Let me hold it there for a minute. Right, 1 second. I think this leg might be a bit bent up. So I'm just going to force down with my soldering iron. Hopefully it will melt and push it down at the same time. There we go. That one. Okay, I think that's okay. I'm just going to put a little bit of solder. I'd rather massive blobs on because these the legs just look like they're sitting a little bit high, but the bridge rectifier is on the ground. Now we're going to get my favourite 99.9% isopropyl alcohol, and we're going to give this a nice good clean up. It's lovely to work on because there's no conformal coating or anything making a mess. So it's nice because when you clean it actually looks clean. Right, okay, so there we have it. New fuse just here, new fuse in the plug from earlier on, and a new bridge rectifier in, albeit a bigger one. Right, I'm going to screw this board back down, and then we'll see what it's doing. What do you think? Do you think it's going to work, or do you think there's something else at fault as well? So, it's now back together. Let's bring it into the other room, onto the battery, plug it in. Let's see now if we have signs of life. Right, I've got it balanced on there, just in case it does explode. It won't leave a hole in the carpet. Right, let's do this one first. I can never remember, is it negative or positive first? I think it's positive, isn't it? Not that it's going to make a difference here. Or maybe it would make a difference. When you put batteries in though, it's always negative first. When you put batteries into devices, you know, you put them on the spring, don't you? Oh, it sparked there. That's is that a good thing or a bad thing? I don't remember it sparking before. I'm going to say that's a good thing. Right, here we go. Slightly apprehensive. Turn it on. Now. No. Still nothing. Oh. No. Still nothing. That's disappointing. So I wonder what's blown now. Wonder if the fuse is gone again. Right, we're going to have to follow the path through it more. Yeah, it should be on now. Try holding that down just in case. No. Okay, back over to the mat. Oh, what a shame. I'll just zoom right in and have a look at the components. So I think we're going to be okay. I mean, what we could do is, I could plug it in just to see if we definitely have the voltage coming out here. At least that tells us that this side is okay. So let's go to DC. Do not copy what you see in my videos. I'm keeping my hands well clear. There's no kids or anything that's going to reach up and grab anything. It's just me here. So I'm just going to go on the capacitor just to see what voltage we have. So I'm plugging it in now. And I'm being careful with my leads, hands well away from the probes. There you go, 330 volts. So we know we're okay to there. Right, I'm going to unplug it. We know we're okay to there. So I've fixed that side, but now, yeah, I mean, it could be, problem is it could be anything. Let's see the voltage disappear on here. So we now know that all this part of the circuit's fine up until here. Unless it was this switching transistor that failed, that then maybe took out the bridge. Unless I unsolder this, maybe it's this, because I mean that is doing a lot of work. But let's say if it had, unless it's open now, maybe it went short, took out the other components and then blew open. Because otherwise it would take out those components again now. I'm going to take a guess that it's either this thing here or this little thing here. I think this little 6-leg tiny little chip is responsible for the switching off the transistor. Weirdly though, I can't find any evidence of this online at all. When I type the number in on top, it's not coming up. But luckily, the transistor has nice big clear writing on, and I can find a data sheet on that. So let me just show you the data sheet of what that is, and at least then, if that's faulty, it means we can replace it. But if this little 6-legged IC is faulty, we can't replace it because it doesn't exist according to Google. I think I'm going to struggle on this one. So basically, when it comes to the massive transistor type thing, it's a MOSFET, an N-channel MOSFET. It's 7 amp, 650 volt, and I've got a data sheet, ground, drain, and source. So that's all fine. The problem is, this other little chip, I'm not saying that this is... I'm just wondering what's doing the switching, you know? Where's the chip that's doing the switching? So I presume it's that. And that's labelled up as 281. I thought it was B53, but I think it's 853. And nothing's coming up. Whether I type in 8, it's just coming up with some sort of chips, crisps, which would be nicer. But yeah, whether I put in 8 or B, it's not bringing anything up whatsoever. So, I don't know what to do with this one. I mean, I could unsolder this. Could unsolder that and put it in my component. Okay, let's do that. Let's unsolder this, put it in my component tester, just to see. But if that's gone, would it not take out this chip as well? Because you can see that they're linked. You know, this goes down here to here, that goes to this leg here. So, yeah, I don't know. So this takes a good 15 minutes or so to get out because it's attached to a massive heatsink, and the job of the heatsink is to remove heat, and guess what? That's exactly what it does. So when you put your soldering iron on it, all the heat is just getting sucked away. So although you can get the solder to melt, it's very hard to actually get the solder out of the holes. As well as that, I've got to undo the 2 massive anchor joints that hold down the heatsink to the board as well. So we've got 5 things to undo, but by far the hardest are the 3 from the actual MOSFET themselves. It takes ages to clear the holes, even though I'm putting in fresh leaded solder into it to lower the temperature, and I'm using plenty of solder wick on it and flux. They're really hard to get all the solder out. And of course, you see, I don't want to use excessive force because I'm going to break the MOSFET just like I did when I was working on the Ubiquity network switch. And of course, I don't even know that this is faulty yet, so I don't want to be just breaking components willy-nilly. Anyway, eventually I do get it out along with the heatsink, and then I discover this. See, I want to be able to pull it, but I can't pull it because it's too hot. It's just very awkward. Hallelujah! It's come out. Excellent, it's come out. Brilliant. Right, that's great news. Let's see what you are testing. It looks absolutely fine. Oh, hold on. No! Yes! Yes, 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 yes! Look at this. I would have never seen this unless I was to unsolder it. You ready? Focus. What do you see here? You see a nice burn mark, and look at the actual MOSFET itself. Can you see there? You've got a burn mark there. So I think what's happened is this is completely blown open. It's not testing short or anything. I think it's just blown open. Let's undo it from here. No thermal paste. Is that normal? If it's not metal, do you still need a bit of thermal paste? I would have thought a bit of thermal paste would have been useful there. Let me know what you think in the comment section. Well, let's get my little tester. Well, let's see if it's going to come up with N-channel MOSFET. I think no. Oh no. Oh no, what? Hold on a minute, leg 1, is leg 1 gate? Gate, drain, source, they've even got the legs right. What? gate, drain, source. Ah, no. But it's got a burn mark on it. I mean, did something else cause that? Right, hold on a minute. Let's zoom in here. You can clearly see, and this isn't the soldering iron, you can clearly see a scorch mark here. And look, you can even see like a proper arc in there, yeah? Now, on here, there is nothing. But there is that insulation thing. You don't think that some water or something sat on top of that and then shorted between the middle pin and the edge pin? Which way is the arcing going again? This side here. I mean, that can't be conductive, can it? That's the whole point of it, it's an insulation thing. Let me just see. No, so it's not conductive. But it's very close. Can you see how close it is? I know it's got flux on it now, but meaning that is going to be near enough touching all the legs, is it not? Well, no, we're only going to be that high. Yeah, right. I'm going to say that it's failed, even though annoyingly it's testing okay. Right, again, if it works, I'll buy one. But right now, look here, I've got an IRF 840, which is 8 amp 500 volt. This is 650 volt, 7 amp. But again, we're not going to be getting up to 650 volts, are we? So if you have a look here, we've got gate drain source, and it's an N-channel MOSFET. And this one here is gate drain source, and it is an N-channel MOSFET. So I think I might just pop this in just to see if it comes alive. If it does, then we can buy the proper ones. Let me just double check how much the real ones are. Right, I can't actually get the same brand because it's down in US dollars, and there's nothing on eBay in the UK, or from what I can see, a UK site. But when I type it in, it is coming up with 7N65. So maybe this is just a long-winded way of their manufacturers calling this a 7N65. And I can buy them. You can get a pack of 5, but it looks like maybe they're coming from China again. I'm not too sure. Anyway, I'm going to pop this one in. Look, it might not be switching fast enough. It might go up in smoke. But the thing is, it doesn't work as it is at the moment. Right, 1 second now. This is going to have to be insulated from that, isn't it? I'll tell you what, I'm not going to put this in for the moment, just to see if it comes alive, because I'd have to put a little mica plate on it. Yeah, 100%, this wasn't me, unless, no, when I lifted it up. No, this wasn't me. This must have been where it originally failed. Look, I can't believe that thing's actually testing okay. But can you see here? Do you know what I'm wondering now? You can see it's shorted between here and here. I wonder, has it taken something else out now and the actual MOSFET itself is okay? You know, maybe it just did this, took out the bridge rectifier, took out a few other things. And maybe the MOSFET itself isn't faulty. But look, that wasn't me. You can see that's been burnt because it was black. And there as well. If it was me with the pulling out, I would have probably taken it out from the, you know, the middle of the pads where I was pulling it. But this has come out from this end. So clearly something has kind of water or something sat here. And it's shorted between this one and this one. And in fact, hold on 1 second. This one and this one. Where is this one linked to? This side goes down to the resistors around to here. Yeah, so it goes down here, around here, to here, to here. So it could have taken out this little chip, maybe. Shall I see if that resistor's been taken out? No. No, it hasn't. I think the resistors and stuff look okay. I'm actually going to leave this off for the moment as well. I think we'll give it a go. This might not end very nicely. Alright, I know this is not going to work. I think it's that little chip that controls the MOSFET. Right, is it going to spark this time? Don't think so. Right, here we go. Let me put it over here so it doesn't blow up in my face. And I'm going to turn it on now. And on. No, still nothing. Completely dead. So nothing I've done has made any difference. What a nightmare. Well, that was really, really irritating because I found problems. But I'm still confused why that MOSFET is showing okay if there's clear burn signs on it. Do you know what? Something must have gone across that, be it a bug, there's no evidence of a bug, but something must have gone across that got burnt off. But in doing that, it shorted and it took out other stuff. We know it took out the bridge rectifier. We know it took out... Thing is, that must have been the source of it, mustn't it? That MOSFET must have been the source of it, because if the bridge rectifier went, why would it cause a burn on the MOSFET? I don't think it would. Something looks like it sat there, some liquid or something sat there, and I think it shorted between those two pins, which is fine, but then you would think that would have blown the MOSFET, but yet the MOSFET's still reading okay, and clearly I've changed the MOSFET out for a different one, and there's still no signs of life. I think it's the switching, that tiny little 6-pin IC where when I type in a number it brings up some crisps.
A little bit later.
Okay, I've been having another look at this, and we know that there was damage around this MOSFET here. And basically I've been looking around the resistors, because there's two resistors here that's feeding one of the legs, when in fact it's bringing the legs down to ground. And to me, they look, I thought maybe I scraped them or something, but they look different than all the other resistors. I'll zoom in a minute. And also they're down as R680. And R680 is only a 0.68 ohm resistor. In other words, it's a full short near enough, isn't it? Yeah, so when I go across here, we're not getting anything like that. We've got a reading in the thousands of ohms. So if you have a look, if I go between this one here, they're both parallel to each other. We've got 144,000 ohms, not even 144, it's K ohms with the K there. So that's 144,000 ohms. So that's not right, because look, there's nothing else in circuit to interfere with it. It's its own little thing. And remember, this definitely has had some sort of massive surge on it, hasn't it? Because it's taken everything out. So there's these ones here. So look, this is the MOSFET here, 1, 2, 3, and it goes down to here. Now look at these resistors. They're nice, aren't they? Look at these resistors. They're nice. You can clearly read everything. You can't read these properly, can you? Look, it looks like they've got like bubbling paint going through here and through here. Can you see there? They look damaged in the middle compared to everything else. Yeah, look, there's more resistors up here. Look how perfect that is. So the very fact they're not reading right and they don't look right, I think them two are faulty. So R10 and R11. You can see they're in parallel from here to here. Now annoyingly, these are easy to get hold of, but I haven't got any, which is always the way. But if you have a look here, I've got a little junk board here, which was a power line adapter. And can you see I've got these? These are smaller, because these resistors are actually quite big. If you look at them compared to my probe. Yeah. So let's go there to there roughly. And if you have a look here, these are a lot smaller. Really about half the size, yeah, and they're the wrong value. But what I'm wondering is, these are 2R2, which is 2.2 ohms. So the other ones are 0.68 ohms. These are 2R2. But how about if I put them in parallel with each other? In other words, stack them on top of each other. They will then become 1.1 ohm resistor, which is still too much. I would need to put, I think, all 4 of them on top of each other to get the same value. But I need 2 on here. So these are already in parallel, so these are going to be halved again. So I presume the ohm reading between here and here should be around about 0.3 of an ohm. So what I'm going to do is, just to see, and if it works, I'll quickly turn it off and then I'll order up the proper ones. But I'm going to put these two on together and these two on together. So basically, I'm putting all four, if you like, together going across there. Let's see if anything happens, because at the moment we're in the thousands of ohms. This will bring it down to one, well, between all of them, it will bring it down to 0.6 of an ohm. So it's still twice the value, but maybe it will be enough to get this thing to start. So that is what I'm going to do. Now, this video is dragging a bit, so I have to speed it along. I take all four of these off using hot air. I then take off the two faulty using hot air on the board I'm trying to fix. And then I soldered these on. I double-decker them like a double-decker bus. Yeah, so one on top of each other. And I do that with the soldering iron. And you know what? It all comes out okay, but they are a lot smaller. But this is only for testing purposes. I haven't got the correct resistors put in. This is an Advent video where I want it all wrapped up within the day. That's why I'm having to kind of like bodge things together to get it to work. But if I can get it to work, I'll happily buy the correct R680 resistors. They're not rare, you can get them, it's just that I haven't got them. Okay, so there we have it. You can see they're doubled up. So each of them now should be 1.1 ohm. So if we go between here and here, we should have 0.6 of an ohm, I think. No, sorry, 0.55, but my meter will not be accurate enough for that. Loads of people say to me that I can hit this button here, but it doesn't zero it on my leads. So watch this. I'll touch this together. You can see my leads are 1.9 ohms at this moment, but it will vary all over the place. In fact, it's varying now while I'm speaking. But look, if I hold this down, unless I'm using it wrong, it doesn't do anything. Yeah, it's not zero in it. Anyway. So really, this should be the same as my leads touching together. 1.75. While before, it was, what was it? In the hundreds of thousands, wasn't it? So let's see now if it's going to work. Remember, I can only have it on for a second because I haven't got the heatsink on here. So between here and here, 2 ohms, yeah. But my leads, I like 1.4, but again it will vary every time I touch it, it will change. Okay, so now, of course I'm nervous because not only have we got, the only thing that's the same is the fuse. I've put a different bridge rectifier in, I've put a different MOSFET in, and now I've put different resistors in here as well. So, yeah, I think there's a very good chance that things may go bang. Is this going to be enough to make it start up? Interesting to see. I'm only going to put a couple of screws in. Actually, before we test, let's see what the old resistors are reading when they're out of circuit. They should be the same. They should still be thousands of ohms. So they're completely blown open. So what I seen in the circuit was, hold on a minute. Yeah, so the circuit itself was all those hundreds of thousands of ohms. They're completely blown open. There's nothing there at all. Interesting. I think we may have now found our fault. All right, Nervous Neris is in town. So, put on the positive. We're on. Put on the negative. It sparked. Okay, here goes. Oh, I hope it doesn't explode. I am going to put it here, so if it does do an immediate massive bang, it will not burn my carpet, but saying that, it's probably more dodgy to be on the battery. Oh, here goes. I'm going to just come back a bit in case it blows up in my face. You ready? Go. Come on. Oh, yes! Yes, 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 yes! Amazing. Start changing. Oh my word. Motorbike 12 volt, 12 volt winter. Car 12 volt, 12 volt winter. 6 volt, 6 volt, 12 volt, 12 volt for the motorbikes. Let's just quickly see if it's going to start charging, and then I'll have to turn it off. Yes, it's charging, it's charging, it's charging, it's charging, it's charging. Right, turn off. I fixed it, I fixed it, I fixed it, I fixed it. Yes. Oh, right, okay, I have got to... Let me have a think about what I'm going to do now. Right, I'm going to do something possibly foolhardy, but I was going to just put a mica plate on. So you know the MOSFET that I've put in has a metal back while this one doesn't. Well, these are little plates that you can get. I think I did a Bang & Olufsen video and people told me about them. They're like a kind of insulation plate that you would put on there, and then you would put this through there as well, and it would insulate everything. The problem is, this is too big for this because obviously it's not been designed. Yes, you could drill the hole bigger and stuff like that, but I haven't got a tap, so I can't, you know, tap a new thread on it. I think, after looking at this very closely, that it was possibly the resistors that blew that caused the spark across here, because if you have a look, remember we are talking about mains, so there would have been probably quite a bang. If you have a look, this here is not the actual MOSFET. This is outside. That's burnt onto the MOSFET. You know? I don't think that is the MOSFET here that has actually burnt. And remember when we tested it, it was testing okay as well. So I think this is just a component like the resistor that exploded near it, and the explosion went in this direction. So I've shown you it working. So if I mess it up now, as far as I'm concerned, this item is kind of unfixable with the amount of things that you had to replace on it. But it's still a successful video. So I'm going to put this back in because I don't think this is actually faulty. So I unsoldered the incorrect MOSFET that I put in, and I put the original N-channel MOSFET back in again, the one that's designed for this circuit. I do put a little bit of thermal paste on it, just because I think it may help it a little bit. And then I solder it all back in, and that's it. We're ready to test now with the original MOSFET, but with two different resistors, well, four different resistors that I double stacked on top of each other, bridge rectifier and two different fuses. So let's see now, is it going to work with the original MOSFET? Then 100% we've proved all the faulty components in this one video. Okay, I was very confident, and now when it comes to plug-in time, I'm not so confident. So here we go, original MOSFET back in. Let's turn on. Yes! Excellent. Oh, fantastic. So it was the fuse in the plug, the fuse in the device, the bridge rectifier, and the two resistors. Let's see if mode's working. Yes, it is. There we go. Brilliant. Okay. I don't want to leave it because the wrong resistors are in there. I'm going to order up those resistors. Let's just see if it starts charging, but I'll turn it off straight away. There we go. Charging. Brilliant. Well, I got there eventually. Why? What happened? I mean, I don't actually know what failed there. It's weird, isn't it? Unless... What took out? There must have been some... Do you know what? I don't know. I don't know what would have caused that, because there was something catastrophic for everything to go, but yet the MOSFET's working. So what would have caused that failure there? Do you reckon there was some liquid or something on the board that then just shorted and took out? I don't know. Oh, do you know what? Could it have been the bridge rectifier that failed, that then took out the resistors and then went back and took the fuses out as well? Possibly. I'm going to say it was the bridge rectifier that failed, but you put it down in the comments what you think. Oh, I really enjoyed that one there. So I will see you again for another Advent repair tomorrow. Thanks for watching, everyone. Whoa, before you go, I've got a quick question for you. I ordered up some R680 resistors, nice big ones. They're 1206 size, which I think is 30 something mil by 16 mil or something like that. And I went for Bournes because I remember them from the resettable fuses that I got, and I remember I liked them. They look like nice products. The only thing is, these are a 1/4 watt, and it was only after I bought them I also realised you can get 1/2 watt and 1 watt. Does it make a difference in this application here? Will a 1/4 watt be okay? I think these might be current sense resistors, because that's when I looked up this R680, a lot of them said current sense resistors, but I'm just not too sure about this watt size of things, because I mean, I might have taken out 1 watt, the 40 ones might be 1 watt, and now I'm putting in 0.25 of a watt. Is that going to be okay?
Clearly, nobody's going to know for definite. It's just like an educated guess, which I can't do. Obviously, if we had the schematics for it, then you would know this. If you're the manufacturer, you would know this. But my watchers, if you could just let me know what you think, because clearly, if everybody's saying you need to put 1 watt in, then I'm not going to put 1/4 of a watt in. I will just buy the 1 watt ones. But I'm just wondering if they're 1206 in size and they're 680, how important in this application here is whether it's 1/4 watt or 1 watt. Questions, and more questions. Hope you enjoyed the video. Hopefully I will see you again tomorrow if I can get another fix done in time. Thank you so much for watching.